down the group, the number of shells increases, and this since the shells are farther away from each other, that's why this size of the atom increases. Another factor is that as more and more shells are added, there is screening effect. There is a screening effect of these intervening electrons, which prevent the nucleus from attracting fully to the outermost shell. This is another factor which leads to the increase in the atomic size. So down the group, as we move down the group, atomic size increases. As we move along a period, it goes on decreasing. That is why these, since they are at the extreme left side, they have the largest atomic size or atomic radii, as well as ionic radii. Then we have number third, we have ionization enthalpies. Ionization enthalpies. We know that ionization enthalpy is dependent upon the atomic size and the screening effect. Since we know, as we have just said, that they have largest size in their periods, the result is that the outermost electron is loosely bound. Since they have a large size, it is farther away from the nucleus. That is why they require lesser amount of energy to get ionized, to remove the lost electron. So their ionization enthalpy values are lowest in their respective groups, in their respective periods. In each period, we can see that ionization enthalpy of the elements of this group first is lowest. Okay, so this is with respect to the other groups. They have lowest ionization enthalpy. But when we move down the group, it is further decreased because the size increases, size of atoms increase as we move down the group. And there is this screening effect also, which prevents the outermost electron from the, or which reduces the force of attraction of nucleus for the outermost electron. As a result of this, these electrons become looser and looser as we move down the group, and this leads to the decrease in ionization enthalpies. Okay, so this is ionization enthalpy. Then let us discuss some physical properties of these alkali metals also. Some physical properties also. Okay, number one is melting and boiling points. Melting and boiling points. Here also the melting and boiling points of alkali metals is lowest in their respective periods, and when we compare them to other metals. This is because they have only one electron in the outermost shell, and which they lose in order to attain the anode pair, this anode gas configuration. Since they lose only one electron, we know that we have like this. When we lose, when these metals lose electrons, they form kernels like this, and electrons are metallic bond. Here we see that is the simultaneous attraction of these kernels for these electrons. Since when there are only one electron from each atom, it means that compared to metals, we have iron, we have aluminium, which lose 2-3 electrons. So there is a higher attraction between electrons and kernels, which produces a stronger melting bond. But here we know that only one electron is lost, and there is a weaker force of attraction between these kernels and electrons. That is why these are held loosely, as a result of which melting points as well as boiling points are lowest. Because since when there are weaker attractive forces, smaller amount of energy can help these to get dissociated and change it into liquid state and then into gaseous state. Okay, then we have density. Density is another physical property. Density. Density of these is again, it is lowest in their respective periods. When we compare them to other groups, this density of these is lowest. Why is it so? Because this is really related to their atomic sizes. Since they have bigger size of atoms, okay, so larger gaps are left between these. Okay, when atoms are bigger, larger voids are left between, and this decreases the density of the metal. Since we have already seen that they have largest size within their periods. It means that when we are compare an alkali metal with corresponding elements of its of their periods, we say that they have a larger size. When they have larger size, their voids are left. It means that empty space are left, and therefore density is reduced. Then we have electropositive character. Electropositive character. What is electropositive character? It is the ease with which an atom of an element loses electron. If it easily loses electron, it is electropositive. It's more electropositive. If it loses electron with difficulty, with where more energy is needed, then it is less electropositive. And here we have seen that these elements, since they lose only one electron, okay. First and second. Second is that they have larger sizes. They have ionization enthalpies are lower. They look at lower small amount of energy. That is the net result is that they easily lose electrons. It means they are highly electropositive. So within each period, the elements of alkali metals are highly electropositive because of the ease with which they lose electrons. Okay. Then we have oxidation states. Oxidation states. The elements of this period show of these alkali metals show oxidation state of +1. Okay, only one oxidation state +1. This is evident that since they have only one electron in ns, that is the s orbital of the valence shell. They have only one electron, so they only lose this electron to attain the electronic configuration of the nearest inert element. For example, lithium attains by losing electron, gets the electronic configuration of helium. Sodium gets that of neon. Potassium that of helium, neon, argon, by losing only one electron. So they show the oxidation state of +1 only in their compounds. Okay, thank you.